Hello, this is part B of the Chapter 6 lesson. In this part, we're going to talk about confidence interval estimates used to compare different populations. And so what we're doing here is we have two different populations, and we want to compare parameters from each population. Maybe we've got a mean in the one population that we want to compare to the mean in another population. Or in part C, we're going to talk about we want to compare a proportion in one population to a proportion in another population. But this is the idea. We have two populations, and we're trying to compare parameters from each population. So to illustrate this, let's make this observation. Men typically have a higher systolic blood pressure than women on average. So a question we might ask is, well, just how much higher? Is it just a half a point higher, or is it 5 points higher, or 10 points higher, or just how much higher is it? So to start to answer this question, first we need to define our parameters. And so our parameters are mu1, which is equal to the mean blood pressure of all men in the United States, and then mu2, which is the mean blood pressure of all women in the United States. So two parameters, we have two populations. We've got all men and all women. We're interested in the mean of this first population compared to the mean of this second population. And so specifically, we want to know the value of mu1 minus mu2. That's our question, just how much higher is that blood pressure for men than women on average? So in order to know the value of this number exactly, we'd have to go out and test the blood pressure of all men and all women, calculate the mean of the men, the mean of the women, and then subtract the two, and we'd have the exact value. Well, that's impossible to do. We can't go out and measure the blood pressure of all men and all women. So we're not going to know the exact value of this difference. So suppose we go out and we get a sample of 1,600 men. We take the blood pressure of each and we calculate a mean blood pressure of 128 with a standard deviation of 17.5. And then we go out and we get a sample of 1,900 women. We take the blood pressure of each, get a mean of 126.5 and a standard deviation of 20.1. So this number right here is a point estimate of mu1. This number right here is a point estimate of mu2. So then we could calculate a point estimate of this difference, mu1 minus mu2, by taking the difference of our two sample means, 128 minus 126, and we get 1.7. So that is a point estimate of mu1 minus mu2. So that tells us that mu1 minus mu2 is approximately equal to 1.7. Well, as in part A, whenever we estimate something, we want a measure of the accuracy. So just how accurate is this estimate? And we're going to estimate this, measure this using a margin of error, and then use that to calculate a confidence interval estimate. And so we're not going to talk about the formula for the confidence for the margin of error and the confidence interval estimate of mu1 minus mu2. The book talks about it, and it's a little bit complicated. We're just going to focus on understanding how to calculate it in the Excel and what it all means. So if we go to the workbook chapter 6 and the worksheet independent samples, we can enter our sample statistics here in these yellow cells. Here's the sample 1 and here's sample 2. And then the green cells are automatically calculated. Here that calculates what the book calls the pooled standard deviation, and then here it calculates the margin of error, and then we have the lower limit and the upper limit. And so that's all there is to calculating a confidence interval estimate of a difference like this. So our confidence interval is mu1 minus mu2 is somewhere between 0.45 and 2.95. So we would interpret this by saying that we are 95% confident that mu1 minus mu2 is somewhere between 0.45 and 2.95. Or in other words, we would say that we are 95% confident that the mean blood pressure of all men is between 0.45 and 2.95 units higher than the mean blood pressure of all women. So men's blood pressure are somewhere between about a half a point higher and 3 points higher than women. See? So there's the answer to the question, or at least as close as we can get to a precise answer. We're never going to be able to find the exact answer to our question, but using a confidence interval, we can get a range of possible values for our answer. Now the book talks about certain requirements for these different types of confidence intervals. One of the important requirements for this type of sample is that our data come from two independent samples. What that means is that the values in one sample must not affect the values in the other sample. In this case, one sample came from men and the other sample came from women, and we'll assume that the blood pressure of the women has no effect on the blood pressure of the men. Okay. But in our next example, we're going to see a scenario where this requirement is not met, and so we're not going to be able to use this type of confidence interval that we just talked about. So this is example 6.7 from the textbook. Suppose we create a diet and exercise program designed to lower systolic blood pressure. One question we might ask is just how much does the program reduce blood pressure on average? Does it reduce it by just 1 point, or is it 5 points, or 10 points, or just how much does it reduce the blood pressure? So the parameter that we're trying to estimate here, we're going to call mu sub d. Mu because it's a population mean, and d because it's a difference. And so this parameter would be defined as the total change in blood pressure of all people on this diet in the United States, and divide it by the total number of people in the United States. So we're interested in the average change. So by change we mean we're going to take their blood pressure at the start, subtract their blood pressure at the end. That's going to be their change. So we want to find the total change. So we'd have to give this diet to every single person in the United States, and then calculate the change of each person, add up all those changes, divide by the total number of people in the United States, and that would give us the exact value of mu sub d. And so our question is really, what's the value of mu sub d? Well, this is impossible to know because it would require us to give this diet to every single person in the United States, and that's just not possible. So we're not going to know the exact value of mu sub d. So instead we're going to go out and give this diet to a sample of people and calculate the change of each person in this sample and use that to estimate the value of mu sub d. Okay. So suppose we put 15 volunteers on the diet and program and record their blood pressure at the beginning of the program and at the end. And so if we go to the workbook chapter 6 and go to the worksheet titled Matched Samples, we see this data given here. Okay, now this data comes from the book, and so from the first person, their blood pressure at the beginning was 168, their blood pressure at the end was 141, and so their difference was negative 27, or their change was a drop of 27 points. Second person had a blood pressure at the beginning of 111, blood pressure at the end was 119, so their difference or their change was positive 8. That means they actually increased. This next person dropped 17, fourth person had no change, the fifth person dropped 30, and the last person had an increase of 8. And so here we have a sample of changes or differences from 6 people. Let's make an observation about the data in this example. Each person gives us 2 numbers, a beginning blood pressure and an ending blood pressure. And so we say that these data come in pairs or are matched. Each beginning blood pressure has a matching ending blood pressure. And so that means that our samples are not independent. A person's beginning blood pressure has an effect on their ending blood pressure. So what that means is that the requirements for our previous type of confidence interval are not met. So we're going to have to do something different. And something different that we're going to do is described in more detail in the book. But to understand how to do this calculations, we're going to use the workbook chapter 6 and the worksheet matched samples where we had our data. We're just looking at a different part of the worksheet. And so here we calculate, or we enter our confidence level. The workbook automatically calculates n, our sample size. This is our number of pairs of data. And then it calculates the mean of the differences. So it takes the numbers in that last column and calculates their sample mean. So we had a mean difference of negative 5.267. So people in this sample, on average, lost about 5 points on their blood pressure. The standard deviation of those differences calculates standard deviation of 12.8. And then it calculates a margin of error and a lower limit and an upper limit on our value of mu sub d. So again, the mean of our differences was negative 5.267. That number is a point estimate of mu sub d. It's a one number estimate of mu sub d. It's a sample mean of those differences. So that tells us that mu sub d is somewhere around negative 0.5267. And so that gives us an estimate of mu sub d. But again, we want to ask the question, just how accurate is this estimate? And our confidence interval given over here and margin of error give us an answer to that question of just how accurate is it. Okay. So kind of summarizing our results here, our 95% confidence interval estimate of mu sub d is mu sub d is somewhere between the lower limit of negative 12.36 and the upper limit of positive 1.827. So we would interpret this in the same way as every other confidence interval. We would say that we are 95% confident that mu sub d is somewhere between these two numbers. Okay. So a negative number means that the diet lowers blood pressure. A positive value means that the diet raises blood pressure. And so we would say that the diet could lower the blood pressure by as much as 12.36, or it could raise it by as much as 1.827. Or mu sub d could also be 0. 0 is somewhere in between this negative number and this positive number, so mu sub d could be equal to 0, or it could be very, very close to 0, meaning that the diet just doesn't have any effect on blood pressure. And so based off of this, we might ask the question is, does the program work? The program was designed to lower blood pressure. Does it really lower blood pressure? Well, based off of this, we're not really sure. The mean of the difference could be negative, means that the program works. The difference could be positive, means that the program doesn't work or has an opposite effect of what we intended. Or mu sub d could be 0, meaning that the program could have no effect. And so we're just not quite sure. So we would say that there is not a statistically significant difference in blood pressures from beginning to end. The differences could be very negative, the differences could be positive, they could be somewhere around 0. There's just not a statistically significant difference. So in this case, our data is a little bit inconclusive as to whether the diet is effective or not.